We can easily imagine the three spatial dimensions: height, length, and width. Albert Einstein discovered that you have to add time as a fourth axis to the three-dimensional coordinate system with x, y, and z in order to describe the world mathematically in a better way. But how can you imagine another dimension? Since then, no further dimensions could be properly proven. String theory, for example, needs 11 dimensions, while more advanced versions require 27. Does the universe really have more than 4 dimensions? Can we imagine them? When a star with enormous mass has used up its energy and collapses in on itself due to gravity, a so-called mysterious black hole is formed. You have to imagine it like this. For our Sun, which has a diameter of 1.4 million kilometers, that's 109 times larger than the Earth, to become a black hole, you would have to compress it down to a diameter of 3 kilometers. Through this process, the black hole swallows everything. Not even light can escape. Space and time are distorted by this structure. Some physicists claim that so-called closed time-like curves can form in such a black hole. Through these, time travel might be possible. It's just incredibly exciting to think about where you would end up if you jumped into a black hole. If you ignore the fact that you'd be dead instantly, some also claim black holes have higher dimensions. "95% of the mass in the universe is made up of a strange matter that scientists are not familiar with. That means all we can see and sense. In the cosmos, only 5% is what we know. The remaining 5% consists of so-called dark energy and dark matter. Our Earth, we humans, the moon and the stars are all made of the matter we know. But that's only 5%. The rest of the entire universe is therefore invisible and a great mystery." The following fact is even more incredible when you think about what we just discussed and then let it sink in. We look at the universe and see how many stars there are, and how much mass there simply is. We just said that everything we see is only 5% of all the matter in the universe. But now comes the incredible part. The average density in the universe is 1 particle per cubic meter. That means if you distributed all the matter in the universe throughout the entire universe, there would only be 1 particle per cubic meter. You have to know that in 1 cubic centimeter of air, there are usually 100 trillion particles. How empty is the universe? Are you realizing how vast the universe is? And it's getting bigger and bigger. Heisenberg found out that you can't observe the tiniest particles like an atom or an electron without affecting their state, because the light you use to determine the position of the particles already affects this world. So you can't determine the initial state, meaning the exact real position and speed of the particles, but only the affected state. But the Heisenberg uncertainty principle says much more. In fact, such a small particle like an electron or an atom actually doesn't have a location, but only has a specific location and state when the observer looks and asks about a state. Nature sets a limit and doesn't show us everything. Because if it were possible to determine the future position and speed of the particles, it might eventually be possible to predict the future, starting from the smallest particles. Heisenberg pioneered quantum mechanics in physics, where particles can exist in multiple places simultaneously, or remain connected over distances. That kind of brings up the question again of whether the moon actually exists when you're not looking at it.